let's talk through the AWS infrastructure. Really, this is the foundation of what's going to be happening on AWS. And there's a global infrastructure that we're going to discuss. To start with, what is the global infrastructure? It's a broad set of services like power, regions, availability zones, edge locations. These are all part of what AWS offers. The foundational services are going to be things like the compute platform. And this would be that you can, basically rent a CPU whenever you would like. Networking, you can grab 10 gig networking. You can grab 25 gig networking. You can grab these very fat network connections, or storage. You can get this concept of infinite storage by using this global infrastructure. And these are all available in these availability zones. And we'll discuss this a little bit more, but an availability zone there's many of them in a region, and there's regions all over the world. And then finally, there's edge locations, and these edge locations are located in many of the same places as the regions. And these are where you can put content so that it can be distributed closest to where the client will consume that content. Now, this is a picture of the regions and also some of the regions that are coming soon across the world. You can see here, this is the West Coast. In this West Coast area, you've got several regions here, including Oregon. And then on the East Coast of the United States as well, the original region here is actually in North Virginia. And you can see that there's several different physical regions located in North America. Europe, there's many regions as well. You've also got Australia. You've got this region of the world as well. You have South America. The South Africa, and also South America. So really, every major region of the world is actually there's some kind of a data center either planned or in progress, and each of these is connected by a physical backbone as well. And so this is one of the more powerful things about this AWS ecosystem, is that not only are there locations all over the world, but they're constantly being developed in other regions. And additionally, there's special clouds as well, including a government-related cloud as well. Now, let's talk about digging into some of these connected regions all over the world here, what's actually involved. And at the lowest level, they're actually data centers. So just like a physical data center that you may have in your company or you've heard of, they're securely designed. That's the first thing to be aware of. And so they're in this shared security model. They're actually going to be responsible for that. So this is something AWS is going to maintain. It's not something you have to maintain. This data center is also in a location where the physical data resides. And this is a big deal in places like the European Union, where they have strict privacy rules. And also, a data center typically is capped out at this 50 to 80,000 physical servers. So they do this intentionally so that there is a very limited amount of risk. And all the data centers are also online. There's no kind of off-site or cold data center. And all this is using very highly optimized AWS custom equipment. And you can see here that in an availability zone, and we'll get into this later, has multiple, either one or more physical data centers in an availability zone. So now what about a region here? We showed that on the map, that there's all these different geographical regions, and a region they're located all over the world, and they're made up of two or more availability zones. So you can see in this picture that there's an availability zone right here, and then typically these availability zones have multiple data centers, right? So there's redundancy there. And also a region, you can actually select multiple availability zones. So let's just say this is, 1A, this would be 2A, this would be 3A, and this would be 4A. So you've got actually 4 availability zones that you could design your application across. And what this means is that even in the case where there's a physical outage of one of the data centers, you've got many times redundancy at the data center level, plus you also have redundancy because you have 4 different availability zones in this exact region. So there's tons of fault tolerance that's built in. But really, a region, to be clear, is a geographic area. and it really means that there's 2 or more availability zones. That's how they're designed. And you also can control the data replication across the region. So there is a charge for moving data across and back and forth, and it's up to you to decide how to do that. But there is a very high speed connection here between these actual physical data centers as well. So that's something to be aware of as well when you're dealing with these availability zones. And a few other things to talk about in terms of this is that AWS will never move your data out of a region where you put it into. So it's your responsibility to move that data into that region. And part of this is through privacy and also through regulatory environments. And if you're leveraging cloud services, you can easily deploy your application in multiple regions as well. And so these are all things that are part of designing a cloud native application. Now let's talk about these availability zones in more detail here. Each of these, again, is made up of 1 or more data centers, right? And these are 50,000 to 80,000 machines a piece. And then these are highly interconnected as well. So we've got a backbone, and they're designed for fault isolation. So what this means is that if there was some kind of an outage as well, like let's say there's a natural disaster and there's some kind of a fire or something like that here, that they're physically isolated. And so that means that fire is not going to affect this other data center, right? They're designed for file isolation, but they also have very fast speed connections as well. And so these private links are really one of the top features of these availability zones. And this means that you can have a database that will span across both of these availability zones. And so an AWS best practice is to build your applications across multiple availability zones. And this really takes over and gives you the security in case there is some kind of a natural disaster in one of those availability zones. And we've had this recently, many instances like fires, for example, or natural disasters. Now let's talk a little bit about these edge locations as well. So edge is a place where users are able to access the services. And you can see from this match here that the blue is edge locations, the purple is multiple, and then the larger circle are regional caches right here. So we can see this is a West Coast cache. This is an East Coast, right? And so what happens here is that Amazon uses a CDN, and we'll spell that out. It's a content delivery network. And that's a way of delivering data directly to the edge location where somebody may be reading the data. So let's say you're trying to watch a movie on Amazon Prime. Well, they're going to distribute that Prime movie. They're not going to leave it on the West Coast. They're going to distribute it to a CDN that's close to you so that when you stream it, you can have the best performance. And that's really the core concept is think about streaming movies. That content is going to be distributed to all these edge locations so that people are able to stream it in the closest amount of time that they possibly can. And also, this is done through a DNS service. Route 53 can also give a request to the shortest possible location. So if you are using their DNS service, this is also one of the capabilities that it provides. Now let's talk about some of the features of an AWS infrastructure. And this is really part of one of the core offerings of AWS that's really important to know is that AWS is elastic and scalable. So that means that the infrastructure itself is capable of dynamically adapting to capacity. And also in terms of scalability, it's able to adapt to accommodate growth. And so if you have 10,000 users or you have 100,000 users, or if you have 1 million users, AWS is able to scale up to that demand. Now, fault tolerance is a different word. And what that means is that you can continue to operate properly in the presence of failure. And the reason you can do that is the ecosystem, this infrastructure is designed for that. So you can see here that it's highly networked together. That's one of the capabilities. It has a UPS, so this is uninterrupted power supply. It has backup generators, and each of these are physically distinct. And even in the case of these multiple availability zones, they have multiple data centers inside. So it's designed to be redundant. That's a key characteristic of cloud computing. And it's something that many companies couldn't afford to do. They just can't afford that level of redundancy. Now, in terms of highly available, it's often referred to as HA. That means that there's a high level of operational performance and it's a minimized downtime without human intervention. And this is a really key component that's often talked about in cloud native operations. So we'll call this cloud native. A cloud native operation is designed around all of this redundancy, and it's designed so that it has very, very little downtime. And that's really one of the core concepts of highly available. And so what are these core services on AWS? And the core services for AWS include really these foundational services, and they're compute, networking, and storage. And what these do is they provide things that allow you to scale up demand in seconds and allow you to pay as you go. And this can mean that you start off with 2 instances here, and then you move up to 200 servers. The networking, maybe you start with a very small amount of data, like 1K per second, and you can go all the way up to 1 terabyte per second, right? And then in terms of storage, you could start off with 1 gigabyte, and then you could go all the way up to 1 petabyte. And all of this is built into these foundational services, and they're typically around these core components: compute, networking, and storage. Now, the last thing I'll really wrap up here with is that when you're taking the Cloud Practitioner exam, this is really one of the most important lessons that we've covered. And it's important to understand, in particular, these concepts of highly available services and that they're fault tolerant, and also that the foundational services are compute, networking, and storage.